So today we are going to see flow simulation, this CFD. Okay, so for this I downloaded the simplify from the GrabCAD community. So I pasted the link in description below. No issue. Okay, so first step, we need to extract the internal volume of the turbo manifold. Okay, so for this, without wasting time, I already extracted all the volumes of the turbo manifold. Okay, so how to extract the internal volume? See the other video in my channel. Okay, so let's start. The first step is, that is the extracted the internal volume. Then next, go to the application, click on the pre and post. Clicking pre and post, go to the new FEM and simulation. In new FEM and simulation, here in select all the extracted internal volumes. Keep polygon body resolution as standard. After clicking OK, let's create two separate files. That is finite element model files and simulation file. We are not going to change any modeling or any adding feature of this extra techno volume. That's why I'm not checking this create idealized part. If you want to change further or make any modification in the existing internal volume, then then you you only check this create idealized part. Okay, here in solver environment, select Simcenter 3D thermo and flow. Okay, analysis type, the simple flow. Click OK. So as we discussed already, it's create two files, .fem and sim. Okay, here is our simulation navigator and post processing navigator, and this is XY function. This is not used. We generally deal with these two navigators. Okay, then there's the third step in simulation environment, that is the setup of solution. Okay, click on the solution, just name flow simulation, solve a 3D thermal slash flow, analysis type, solution type, flow. Click on create solution. Okay, in solution details, run directory, we need to change to the simulation solution name. It's important because all the backup files and the report and plot graph files are saved in the same folder, in the same folder where you save the part. Okay, so it is important to change run directory to simulation to solution name. Okay, so flow solver function, we are selecting parallel solver. Okay, in parallel flow solver scheme, into the fully coupled pressure velocity, and in turbulence model, it's better to use standard CAE epsilon instead of mixing length. You can use mixing length, no issue, but I generally prefer to use standard CAE epsilon. Okay, then wall distance calculation method, keep geometric scenario. Okay, then another important is solution type. Solution type is steady state, and this one is in error. Okay, uh, this time do not change any solution units and ambient conditions. Keep it as it is. Okay, done. So click OK after setting solution details. Okay, after the setting the solutions, we need to give or apply the meshing. Okay, for applying meshing, switch files from simulation to .fm. Okay, in .fm, go to the 3D tetrahedral. In 3D tetrahedral, change to TET10. Okay, uh, after TET10, select all the bodies. Here in mesh parameters, after selecting the body, click on this automatic element size. Then it's calculate the automatic element size as the 19.4. We required the more fine mesh, that's why we divided by 2 and click OK. Right now, keep everything as it is, not change anything. Okay, then we need to apply the density or material of this extracted internal volumes. Okay, so for this, expand the destination collector, click it new collector. In max collector, here in properties, click on the choose material, select the air and click OK. Okay, keep now its coordinate system absolute as it is, change to air 1 and click OK. Now in single command, we apply the mesh and material also. Okay, otherwise you need to use the 2 different commands and collect it together. Okay, then click it OK. Give some time to apply mesh. After completing the mesh, body look like this. Okay, so remember, this is our inlet and all these 4 it's our opening. Okay, right now we are considering this. Then we need to apply the flow boundary conditions. For this, let's switch to the sim environment. Okay, then go to the simulation object type. In simulation object type, the flow boundary conditions. Okay, flow boundary condition, we are giving this one as an inlet. So here select the inlet flow, then change name, that's a inlet. Here I am applying mass flow, that's a mass flow kg per second. I'm changing to kg per hour to 0.1 and keeping other things as it is, selecting this face and click OK. So this is the inlet conditions. Okay, so now it's time to give the outlet condition. Go again to the simulation object type, flow boundary conditions. Here, go to the outlet flow or opening. If you know the value of the outlet flow of the mass flow rate or any other, then you need to choose this outlet flow, or otherwise if it's directly opening to the environment, then choose the opening. In opening, you no need to add any kind of values. Okay, so here for a report point of view, if you want the separate value, the how much mass flow rate and pressure at this 1, 2, 3, 4, these 4 different openings, then you have to give different opening for these 4 different. Okay, otherwise collectively give one single opening. Okay, for this video I am giving the 4 different opening. Opening 1, using this, apply. Then opening 2, apply. Opening 3, apply. Opening 4, apply. Okay, now we give the initial boundary conditions. Now we require the report at the end, right? So for this, again we go to the simulation object type and go to the report. Okay, in report, per region and between region, there is a 2 option. Okay, if per region, suppose I want what it's the per region, I want report at inlet, and in 3D flow data I'm selecting pressure, velocity, temperature, mass and volume flow. Select it this phase, click OK. We need to follow the same for this all these 4 opening also. So report opening 1, checking same report data. Okay, okay. So now, now we get the separate report of this separate inlet and opening point. Okay, suppose we require the additional report point in between this 1 to 1, what is the pass flow rate and pressure drop. Then we have to select, go to the report, and in between region, if you want pressure drop between 2 region, so SAM report inlet and O1, select the body phase, the single one, and in secondary select this one, want pressure drop, copying this, click OK. The same report and opening 2, pressure drop, primary object inlet, and secondary object in out opening to apply. And 3 primary inlet pressure drop. 4 primary pressure drop. Clicking OK. Now here in simulation object container, you get all the report inlet opening 1, 2, 3, 4. So you can later change it here also. If you want to change the value, suppose in inlet, I want to change mass flow rate to the pressure rise or velocity, then you can change it here also. If you want to change, okay, and delete all there. If you want to delete, then delete also. Okay, so we all the done for our body condition. Now it's time to post processing. Okay, for post processing, we require time to calculate all the things. So it take too much time in this video. Okay, in post processing, only 2 steps is pending. That is, the first is a model checkup. Let's go to the first animation, right click, and this model setup. And after model setup check, we want to check the solve version. And after solve, we get the report, and how to read the report and convergence we see in the second part of this video. Okay, thank you.